Hello, everyone. Thank you so much for joining us today for a conversation with Professor Will Fleischer about navigating the ethical challenges of AI. My name is Kate Walters. I'm from the class of 2003, and I'd like to extend a warm welcome from the Georgetown Club of Boston. Our fabulous president, Mara Kelly, is on here, but she's out of the country. And it's actually the middle of the night where she is in Australia. So talk about Hoya dedication there. Thank you for joining, Mara. Before we dive in, I wanted to share just some quick info on the Georgetown Club of Boston. Our board is made up entirely of alumni volunteers, and we hope to bring you a diverse set of events and activities to keep you connected and maintain that community we all so loved while we were at Georgetown. So if you have ideas of events or programs you would like to see more of, please email us. I'm going to put our club email address in the chat, because we'd really love to hear from you. So now I would like to turn it over to the mastermind behind this event, Mario Damiata from the class of 1970. Mario, thank you for all the time and effort you put into this. I'm going to turn it over to you to introduce Professor Fleischer.
Thanks, Katie. Yes, I'm a member of the class of 70. I feel pretty ancient, but still very interested in doing volunteer work. We selected AI because it's timely and relevant, and there's a lot going on, and we thought it would be a really interesting event here today to talk about. AI is all around us. It infuses every aspect of our daily lives. Probably we're not even aware of when it's happening most of the time. And we thought that bringing in Dr. Fleischer from the college would be, really interesting to talk about. There's kind of like two major questions. One is how should we start to think about governing AI, if we want to govern it at all? And if we do govern it, how do we make AI perform in a way that at least follows some core moral guidelines? And there's just a lot out there to think about. One is intellectual property. If I create original content and AI uses it, do I have to give my permission? There's the issue of disclosure. If I'm reading a newspaper article in the Washington Post, should I know that that's been at least AI generated, or if there's been human intervention in it? What about the issue of privacy? What sort of privacy rights do I have in an AI ecosystem? In higher education, there's the issue of plagiarism and how to create college essays now that AI can automatically generate when you hit the right buttons. There's also facial recognition implications of AI and how it discriminates against minorities. And then there's a whole world of disinformation and use of AI to conduct warfare and everything. So there's so many ethical and moral questions that one doesn't even know where to begin to start, which sort of implies our format today. Dr. Fleischer is going to kind of ground us for about 15 to 20 minutes in how to understand AI and raise the same ethical issues I think that I've touched on. And then we're just going to open it up to Q&A to have you address the concerns and questions that bother you about AI, or some of the positive things you'd like to say about it. With regard to Dr. Fleischer, he's an assistant professor of philosophy and a research assistant professor in the Center for Digital Ethics. He's also affiliated with the Technology, Ethics, and Society program at Georgetown. His areas of specialization are in the ethics of AI and in epistemology. Before coming to Georgetown, Will was a postdoctoral fellow in the experiential AI program at Northeastern and a postdoctoral fellow in the philosophy, neuroscience, psychology program at Washington University in St. Louis. He received his PhD in philosophy from Rutgers University. Please join me in welcoming Will Fleischer.
Hey, everyone. Thanks so much for having me. I really appreciate the opportunity to get to chat with you all. Okay. Yes. So thanks for joining me. I'm going to, give a little presentation to try to get us all on the same page here. It's going to be just a sort of very brief primer on AI and machine learning, and then I'll also do a list of interesting potential ethical challenges and talk a little bit about some of those to get us started. So for any computer scientists or data scientists in the audience, I'm going to make some simplifications So there'll be some places where you're like, hey, wait, that's not quite exactly right, but that's okay. We're going to get all on the same page and then we can get down into the details. Okay, so what is AI? The term is being used all over the place to name all sorts of different things. And these days, most often when you talk about AI, when we began this discussion, really we're talking about generative AI, these new chatbots and image services that people are using. But artificial intelligence, as computer scientists and others have been using the term for a long time, powers like all kinds of different services that you use every day. They help determine what music recommendations you get, movie recommendations you get, what the next video is going to be on TikTok, or any of these other services. They're also used, AI systems are also used to help make all kinds of like really crucially important decisions about people's lives, from the criminal justice system to hiring to credit scores. So AI is used everywhere all the time. So what do we mean by AI? Well, back in the day, what people meant by artificial intelligence was, HAL 9000, Commander Data, like literal other persons that we've built out of silicon chips, right? But that's not really what we mean by it most of the time in conversations about contemporary AI, because there are no such creatures yet. The field of artificial intelligence as a research field in computer science is sort of the attempt to try to get us there. But the kinds of AI systems that people have been building for a very long time are very much simpler than that. So this is the Russell and Norvig book. If you're interested in picking up a book on AI, this is the textbook that like every computer scientist who learns to do artificial intelligence starts with. And the definition that Russell and Norvig use is that the field of AI is the study of agents that receive percepts from the environment and perform actions. In other words, they're things that take in information and then respond to them. And really what we're talking about are, agents, by which we mean a computer system or a program that does some task or solves some problem in a rational way, or at least as rationally as a human would. So we're talking about, anything that is designed to sort of on its own solve a problem that humans can solve, like playing chess really well, playing Go really well, or driving a car, or searching for things in a database. These are all things that are called AI by computer scientists. So to make distinctions, people talk about strong or general AI as being HAL 9000, like a full-on system that's as smart as a human that can do anything a human can do across a wide variety of contexts, maybe better than a human can do them. These are science fiction. We don't have anything like this yet. It's true that generative AI is by a wide margin the closest thing we've come up with, but it's not Commander Data. Okay, my students don't know who Commander Data is anymore, but hopefully this audience will come along with me with Star Trek references. But anyway, we don't have fully intelligent AI yet. So most of the time people are talking about narrow or weak AI that solves like a limited set of problems, but at least as well as a human being does. Those are the kinds of systems that people are developing, and generative AI still is a narrow or weak AI system. It just tends to be more general than what we used to have. That's part of what's so exciting about it. Distinguish AI from machine learning. Machine learning is the set of methods that we use to build AI systems. So this is a wide variety of methods for getting a computer system to improve its performance at a task with experience or with training, where experience or training really just means presenting the system with lots of data as an input and then modifying it over time as we see how it responds to that input. So machine learning is a set of methods for building AI. So, AI agents in the terms that people use range from, when I first learned how to do AI, it was to train Pac-Man to do various things, using machine learning. But, ChatGPT is, of course, a tool built, it's an AI agent in the sense that we've been talking about. Okay, so let's talk just a little bit about machine learning, get this idea here of how this is supposed to work. In machine learning, you take huge sets of data and you train an AI system to compute a particular function, what we'll call a model. So the components of machine learning, you have the data, you have the kind of model you're going to train, then you have the loss function. It's the way that you evaluate how good the system is at doing its task. And then you have a set of optimization algorithms, which we won't talk about too much, but they're just the methods for getting the system to behave in a way that lowers its loss function, that is, makes it better. So just to get a handle on what we're talking about, why we're calling these models. Here's a simple set of models. The curved line and the straight line are ways of modeling a certain data set. That is, here we've got housing, houses. We've got their size in feet, and we're trying to model how their size affects their price. And so both the straight line and the curved line sort of model the relationship between size and price. It's just a function in the mathematical sense that models that relationship. So when you train an AI system using machine learning, what you're training is this model, this function that the computer system computes. So one thing you can do is what's called a classification task, and that's just to apply a label to a particular input. So suppose I want to tell whether a set of images contains cats. I want to train my system to recognize cats. So what it's doing is it's labeling the input images with the label cat. And if it does a good job at that, then that's fine. But if it does a really crummy job at that, we want to improve it. We use machine learning to get the model to do a better job of recognizing cats and images. But the model there might be something very simple, like the linear or curvilinear models that I just showed you, or it could be something really very complex. So models come in all kinds of different types. These are just ways of computing functions. The lines and the curves that we just saw are models, but so are decision trees. These are ways of deciding what to do based on making a sequence of choices. So if I want to decide whether to play tennis, like in this image here, I can, based on the weather, I can say, okay, is the weather sunny or is it raining? And if it's sunny, how humid is it? And by making a series of choices based on those facts, I can decide what to do. And we can train computer systems to make similar kinds of sequential choices over time, which we call a decision tree. That's one kind of model. One kind of function that a computer can calculate in order to decide whether it should recommend to you to play tennis or not. These are very, very simple examples. But of course, what's exciting about AI is that we are getting it to do much more complex things. And we're doing that by using much more complex models. So these are still, we're just talking about functions that the computer is computing to take some input to some input. But now, instead of simple lines or decision trees or simple things like that, we're using these very complicated systems called deep neural networks. They're neural networks because they're very, very roughly inspired by the way neurons work in the brain. They take in a certain amount of input from other units in the network. And if they get excited enough by that input, then they output to the rest of the network themselves, just sort of like a neuron does. Whether or not they get excited enough is determined by two things: how strong a signal they're getting from other parts of the network, and the weights that they assign to each of the other parts of the network they're connected in. So you can see here, I've got on the top of the screen, we've got the unit displayed, and the W's there are the weights. That's how strongly the system is paying attention to previous parts of the network. And then you string them together into networks like these, where each layer, the units don't really talk to each other, but they get input from previous layers, and they send on input to layers afterwards. Again, very roughly inspired by a brain. These are just models. Each unit calculates a very simple function, but then when you string them together, they end up calculating really, really, really complex functions that are hard for us to understand. Now here I've got a network with a couple nodes and a couple layers and some connections. But in the really complex systems that we have now, like GPT-4, there's 1 trillion connections between units. And then, these connections the networks are trained up using machine learning rather than explicitly programmed. And by trained up, I mean, we determine exactly what function they calculate. And what changes when you train them are the weights, the parameters. So you hear people talk about parameters of a model sometimes. When you're talking about linear models, like super simple models like we started with, the parameters are, if you have a simple linear model like you might remember from pre-calculus class, the parameters of that model are the slope, m, and the y-intercept, b. When you change those parameters, you get a different line. So if you were to train up a linear model, you wouldn't do this because it's too simple to do by hand. But if you were to use machine learning to train up a linear model, what you would do is you'd alter the m and b over time to try to get the system to do something more interesting. In a deep neural network, the parameters are the weights. Those are the things that get altered. So you take a deep neural network, some huge set of units calculating individual functions, you present it with a massive amount of data and see what it does with the huge data set. If you're, for instance, using a deep neural network to classify images of cats, did I give my cat image? There's my cat image. This is my cat. So if you're training the system to recognize images of cats, you present it with, 1 million cat images. And you see, okay, did the deep neural network output that all the cat images are images of cats or not? If it did, great. But more likely, it's going to make some mistakes. You measure how many mistakes it makes, and that gives you an idea of how you should alter the parameters of the network. That is how you should change the weights. Now, exactly how that works is very complicated and doesn't really concern us here. But the basic idea is that you just present the system with a bunch of data and you alter it. You change the weights. That's how deep neural networks get trained. Let me skip that. All right, so generative AI is the kind that everyone is super excited about. ChatGPT, Stable Diffusion, DALL-E 3, all these abilities to make images and to have conversations with the systems. These are what we call generative AI. And it's called that just because rather than just like classifying images, like we talked about a second ago, the systems are actually outputting interesting conversations, text, or images in them. We're using them to make things. But the basic building blocks of how these things function are exactly the same as what I just talked about. So large language models are built using a particular architecture of a deep neural network. And by an architecture, I just mean that the way that the units are strung together and the kinds of things that they talk about. Now, this is a very complicated thing on the right here that illustrates this architecture. You can think of each of these boxes as, except for the last one, the softmax. Each of these boxes you can think of as a layer of a deep neural network. That's a little bit of a simplification, but it's something like that. So each of these are like a layer of a deep neural network. And so you just have a huge deep neural network, and there's particular parts that are supposed to play a certain role in the process of recognizing language and producing language. But basically, it's a big deep neural network. So what does a large language model like GPT-4 do with that big transformer architecture? Well, what we're using for, the task we're using it for, most directly, I mean, of course, what we actually wanted to do is talk to us or do all the things that we've seen ChatGPT do. But the initial task that it's doing is next word prediction. In fact, it's predicting tokens, which are actually subword parts that include like punctuation and spaces and things like that. But we think of it as words. So it's trying to predict what the next word would be in a string of text. So you present it with an input string, like the boy went to the, as we see in this illustration. And what it does, what it's supposed to do, is output how probable each word in its lexicon is as the continuation of this. So we're using it to figure out what the next most probable word is. And ultimately what it outputs is the next word, the next token. that it thinks is the most likely. Actually, it's not quite that simple. It doesn't just pick the most likely one. It takes the list of most likely ones and randomizes them a little bit, and that actually makes it more interesting. But we can, you can think of it as like just picking the next word in a sequence. And then doing that over and over again, where now the input sequence, each time it does that over and over again, is the set of words that it's added, as well as the original input that you gave it. And what do you know? You present these things with enough data and train them in the right sort of way, and that next word prediction task turns into a system that you can have a conversation with, or apparently have a conversation with. So, training large language models happens in 2 steps. You might hear about, there's the actual training of the model, where you take trillions of words of text. It's not literally the whole internet the way people talk about, but it's different ones of these have different data sets that they've taken from the internet. They've, one of the reasons why OpenAI has such an advantage is that they have a really good data set they've put together. We think. The rest of us can't look at it. It's proprietary. But they've got this huge set of, conversations, articles, things that they've taken from the data, from the internet, that they've trained the system on. Then after you train up the deep neural network to get all the right weights that we just talked about, they have this system of human feedback reinforcement learning, where basically you present people with the outputs of these systems. You have them have conversations, say, with the chatbot, and you change the behavior of the large language model a little bit on the basis of this input that they get. How that works is more complicated than we need to get into, but it's a moderate changes to the output of the system without making big changes to the model itself. All right, so you take these models that you've trained up and you stick them into interfaces of various sorts, and you get tools, artificial AI tools or AI systems that you can interact with. So ChatGPT is one of these tools that's built on the large language model GPT-4 right now. If you pay for it, you get the GPT-4 version. You can use it to have a conversation. DALL-E 3 generates images for you. I actually used DALL-E 3 to generate some of the images that we've seen in the slideshow. But it's also used in Google Search if you turn on the beta version, and Google Translate, and just any sort of tool that you can imagine, including the ability to tools that allow you to make fake photographs of people, deepfakes. So there's all kinds of different uses that you can make of these systems. But basically, these are AI built using machine learning. They're a development of previous efforts to use deep neural networks to do things like recognize images or to do translation. They're just a particular architecture of model that allows the systems to do a whole bunch of more interesting things. And the capability of the systems are very impressive, though they aren't as impressive, I think, as some people would like us to believe. They're also not as accurate as some people would like us to believe. So if you're having a conversation with ChatGPT, I would not take it on face value, everything it says, to put it mildly. Okay, so there is a whole host of ethical issues for that generative AI raises. Some of them are very similar to previous ethical issues that AI systems have been raising for a long time. For one thing, the data that we use to train these systems are filled with human behavior. Human behavior includes all kinds of intentional, unintentional bias and discrimination, and it reflects existing injustice in society. So unsurprisingly, you get systems that display this bias too. There's opacity issues. We don't understand exactly how AI systems work. We don't know why that transformer architecture is really reliable at producing speech. Of course, I don't know that very well, and many people in this room don't know that very well. But there's actually a sense in which even the developers of the system can't tell you like which part of the model is doing the work to make the model reliable, or why certain changes to the model will make it work better and others won't. We don't know. And then there's questions about who's responsible for the behavior of the model. There's questions, as Mario raised earlier, questions about ownership of the data. There's questions about, is it going to put people out of work? who should control these systems? Monopoly and power centralization issues, especially given OpenAI's competitive advantages. There's misinformation problems. There's research integrity problems. And I've highlighted at the bottom carbon footprint because it's a huge problem because they produce massive amounts of carbon. One estimate was that training GPT-3 alone produced 500 metric tons of carbon. So anyway, they're very expensive. But although I put this in red because I think it's very important, but the issues there are probably not novel to AI, the general kinds of issues that we have about generating power for things. All right, so I have bonus slides to talk about things if necessary, but that's my little lead in, and I'm happy to chat about any questions people have or whatever. Thanks, guys.
I'll ask a basic question, and thanks for taking time to join us this afternoon. How can you expect a governmental regulator who barely could probably understand the first words of what you just presented on to be able to come up with accurate and correct regulations to kind of keep us all from having a Terminator movie in real life from happening when these people barely know how to use their cell phones?
Well, I mean, I think fixing the American government might be beyond my pay grade, but like, you know, there's actually a lot of people in academia, in industry, in nonprofits who have a lot of knowledge, and I think that regulation here is going to require hiring those people to work in advisory roles in the same sort of way that we've been dealing with complex technology that people don't understand for a very long time. Government. I mean, you know, it's we have similar opacity problems with the way drugs work, with the way vaccines work, with the way nuclear power functions, or you know, all kinds of technical issues that legislators don't understand, and which I think that the right answer is that we need good advisors, and you know, it would be nice if we could elect some more competent legislators, but that's a very large problem that on its own.
Well, let me ask, so the way the models are programmed, they're essentially amoral. You give it a set of objectives and it's supposed to achieve those objectives by looking at different alternatives, at different options. And some of those different options would include putting all human beings, let's say, in a zoo or something. If human being becomes an impediment to the objective, the AI program actually either provides an instruction to either kill the human being or to put them aside. So that's in existing AI programs right now. So how do you even begin to manage that when AI programs are just focusing on a single objective?
Well, I mean, it's one thing is that, I mean, we can be smarter about what we choose. I mean, when you talk about them having an objective, this is the loss function I mentioned. That's all the sense in which they have an objective. We've trained them with certain goals in mind, and they respond on the basis of that set of goals. So if we choose better loss functions, we can end up with better behavior. That's one step. Another step is that generally speaking, we probably shouldn't put systems that we haven't tested thoroughly in real world scenarios in charge of things that can kill us. You know, so I think that there are concerns. I mean, I think that the most pressing concerns are in autonomous vehicles and lethal autonomous weapon systems. When we are using AI systems that are opaque to us, if we're going to deploy these systems, it's going to have to be on the basis of like really strong randomized controlled trial evidence, not on the basis of being able to peer into the thing and see why it works. And yeah, and I think that generally speaking, we should not put AI systems in charge of nuclear weapons or you know, give them the ability to round us up by making them in charge of automated weapon systems. But I think the sort of like sci-fi worries are not immediate worries for the most part. The immediate worries are, look, we've got AI systems that we're using for helping us make targeting decisions. And they are optimizing for things other than, say, avoiding civilian casualties. So I think this is a very real issue, but it's going to be in places where we know that we're using a system that's making these life or death decisions for people.
I'm wondering if you can comment on the use of AI in healthcare and any particular ethical considerations from that standpoint.
Sure, yeah. I mean, there's actually a really robust literature going on for a long time about bioethics and AI, AI in healthcare. So there's a whole bunch of issues that come up. One of them is opacity. People are worried that when you use an AI system, say for radiology, and the doctor says, well, the AI looked at this scan and it says there's no cancer, so we're just going to go with that, something like that. Then there's a worry that it's going to undermine decision making because we don't know why the system is making the decisions it does. There's also worries about bias and fairness. So like, AI systems are trained on biased data sets, as I mentioned. One of the ways that they're biased is that they don't have as much data from non-white people. And so it gets worse results for people who aren't from, white American populations. And so that's a bias issue that crops up that people talk about. So those are two issues. There's also questions about, making distribution decisions on the basis of AI. So there's all kinds of issues of bias, opacity, and responsibility and accountability that crop up in healthcare. There's more things to be said about what people have said to try to help solve these issues, but it's really a huge active area of research.
We have a question from Asin.
Thank you, Professor. I really appreciate your time. I would love to get your thoughts. What do you think of the Times lawsuit against OpenAI? What are your thoughts on how that's going to play out?
Yeah, I'm not an expert in copyright law, so exactly what's actually going to happen, I don't know. And I think there's like novel substantive questions, and I don't know how the judges are going to apply precedent, and so that's beyond sort of above my pay grade, legally speaking. But when it comes to like the moral question of like whether we think that what OpenAI did was appropriate, and whether we should understand it as like plagiarism, say, is a set of interesting philosophical and moral questions. I suspect that we should want a property regime that protects people's data and people's publishing. And we might worry about the regime we have right now, limiting access to research to only the owners of the copyright, like the publishers say, is, I think, worrisome for democratic reasons. But just allowing OpenAI to sort of profit off of other people's labor seems worrisome, and having them do it without proper attribution. So I think it would be better if we had a copyright regime that did place some limits on whether these companies could just go take people's published work without paying for it.
How do you see the impact of AI on the future of higher education, especially in the area of writing essays?
Yeah. So this is not this is a big problem. So I like assigning essays to my students. I'm still doing it right now, but my current strategy is to try to insinuate that I'll be able to point out truthfully that in fact the system's going to do a bad job of writing papers, at least by the standards of a Georgetown student. They're not going to get A's using this system for now. Yeah, it's a problem because all of the sorts of methods that we might use to sort of enforce getting people to do the work we want to do from writing essays are going to have accessibility problems. It's going to be harmful for many students. Having more in-class essays seems worrisome. Having intrusive monitoring systems on people's computers seems worrisome. So I'm very worried about this. But I mean, I think ultimately we're going to see a lot of people develop alternative methods of evaluation. And I worry that we're going to lose out on the benefits of essay writing. Not so much the ability to learn to write better necessarily, because that actually won't be as important because we'll have ChatGPT to help spruce up our writing. But the actual critical thinking skills that people are developing by writing essays that I'm trying to get my students to develop by writing essays, it's going to be harder to get them to do that.
A related topic, disclosure rules. So if I'm reading an article in the New York Times, how do we enforce the ability to know if that was AI generated or if there was human intervention in editing it? Is that
Yeah.
all going to be voluntary in the future, or do you think there should be some governance of that?
I mean, I think that we ought to have rules about this. I think that there ought to be laws about this. The actual enforcement of them are probably going to look more like, libel laws, where like it's a really high bar for proving that someone actually, intentionally is defaming someone, intentionally lying. Similarly here, there's no detection system, and I wouldn't expect that there ever will be a reliable detection system for AI for various reasons. So it's not like we're going to be able to enforce it. It's going to be, we're going to find out someone has recorded a conversation of someone else. There's text messages of saying, I'm going to use AI for this project, and then I'm not going to tell anybody about it. So there's going to be a lot of cases where it's not going to be caught. But yeah, I think we ought to have rules, and we ought to come down hard on people who violate them as a way of like trying to avoid having sort of disinformation in the sense of not letting people know that the information they're getting is being computer generated.
We have a question from the chat from Mary Ellen. What cautions do we need to take with the upcoming election?
We should be very skeptical of video and photographic evidence that's being generated. So there's now the ability to produce deep fakes that are very convincing. So we'll want to have, you'll want to trust established news organizations, academic organizations, fact checkers for evaluating the veracity of photos. We're going to see a lot of misinformation again, though. I think when it comes to text, we're not going to see much worse from the fact that there's generative AI, because it's already very cheap to pay people to write misinformation. The issue with misinformation is getting people to look at it, getting it in front of people. And so I don't think that we're going to see new problems from generative AI out of that, though we're going to see massive problems. We're seeing massive problems right now with misinformation. Misinformation about the conflict in the Middle East, the conflict in Ukraine is already just everywhere. The problem exists already, and it's going to continue to be an issue. And it's going to be exacerbated by image and video and audio abilities. So the text abilities, I think, won't make much of a difference.
In New Hampshire, someone generated a fake phone call from President Biden that robocalled Democratic voters and told them not to go to vote in the recent primary.
That's the kind of thing I'm thinking with audio and video being an extra issue here. So I think that people should be careful about where they're sourcing their information. And then we're going to have to think about ways of like stopping things like unauthorized robocalls if we want to see some change made here. Though whether there's political will for that kind of thing is another question.
Is knowing where transformers are effective or ineffective / why they produce certain results something that people are interested in or currently researching?
Yeah, so trying to figure out why the systems behave the way they do is a huge topic of interest in AI. It has been for a long time. It's often discussed in the terms like transparency, explainability, and interpretability. So if you look up those terms, and that's something that I work on from a sort of abstract philosophical level. But there's a lot of methods people have been trying to develop that will explain the behavior of these opaque AI systems, these black box AI systems. Unfortunately, the sort of degree of sophistication and complexity of the systems is increasing at a rate much faster than our explainable AI methods are, because there's a lot more money in building the AI systems to do stuff than there is in trying to explain them. So we were making some progress, and then the transformers came out, and there is very little ability to provide those kinds of explanations for the transformer systems. So people are working, and people have suggested, there are people who claim that they understand them better, I think, than they do. But for the most part, we're at a very early stage, and the development of the systems is just vastly outstripping our explainable AI efforts.
Is there any hope to avoid a dystopian future of ubiquitous telemetry and biometry, where any non-ideal behaviors, e.g. speeding, skipping exercise, undergoing mental trauma, are penalized via insurance premiums?
We could enforce laws to stop people from doing that. Like we have laws against, health insurance underwriting now. So that's good. That seems like a model. So yeah, I think that the hope for avoiding, further erosion of our autonomy on the basis of these AI systems and private platforms that make so many decisions for our lives undemocratically, the hope is democratic oversight, political organization, passing new laws, creating new governance, and that's going to be necessary to make some dent. But I mean, in a way, we're already living that dystopian era. I mean, everything we do is being, the information about what we do is being hoovered up by every single thing you interact with every day, all the time. So unless you don't have a cell phone, don't use a computer, don't drive a car, all this stuff is being gathered already. So, I mean, is it dystopian? Well, there are worse things in the world than these facts, like climate change.
So, well, I want to get piggyback back to Andrew's questions about regulation. Where are we right now with AI regulation? So, the European Union is trying to pass some basic rules for countries to follow, but I don't think it's been passed yet. The White House on October 30th put out guidelines for federal agencies on the use of AI. I'm not sure what Congress is doing right now, but where essentially are we in the regulatory ecosystem?
I mean, I think there's very limited, the very limited existing regulation of these things. The EU is a leader. They passed laws previously about AI, the GDPR, that are in effect, but that was before generative AI came out. So the new EU AI laws is meant to try to respond to this. Well, a draft of it just leaked, though I don't think it's passed yet. So there's some progress on demanding things. We have better understanding of like privacy controls, privacy regulations, and a little bit on the aspect of fairness and classification. So there's like requirements on anti-discrimination requirements that can be enforced. But for a lot of these questions, like there is in the GDPR, which is a previous law, general data and privacy something or other, that governs AI in Europe. There is a requirement for a right to explanation, though making sense of exactly what that is and how it can be satisfied is very unclear. So there's laws on the books, but exactly how they're enforced is another question.
Right.
Similarly, with respect to copyright law, the government's, the U.S. government's, the Biden administration's position is that there's lots of existing law that can be used to regulate things like the use of data in an AI system. And right now it's a legal fight in the courts to see whether the FTC and the Justice Department can enforce those laws as the Biden administration thinks that they can. So we're going to see. As far as like congressional legislation in the US, I haven't seen anything. And I mean, I wouldn't hold my breath for Congress to do something useful.
So it's still going to be the Wild West for a while?
Yeah, I mean, Wild West is a little strong. I mean, it's going to be that a few enormous players make all the decisions. I don't know if that's different than the Wild West or not. Maybe the railroad companies and mining companies are a relevant analogy, but yeah.
Right.
Yeah, so I guess little strong is the wrong way to say that. There is a Wild West analogy here, but it's that we've got these massive corporations that do what they want.
So we didn't talk much about the companies, but essentially it's 5 or 6 companies with a lot of little startup AI companies as well. And if you added up all the AI developers in the world, probably be what, less than 100? But so my question, it seems implicitly anti-democratic right now, the way it's set up. And so maybe the Wild West, isn't the right analogy, but it's certainly very centralized.
That's right.
That makes it inherently scary.
Yes, I agree. I mean, so there's now like 1 million startups doing AI, but when it comes, but like But when it comes to like actual players, yeah, it's like a very small number of companies, and they are associated with existing, massive tech firms for the most part. OpenAI with Microsoft, DeepMind was bought by Google. Anthropic is independent but has a lot of venture capital funding from existing players,
Just a question, how do you envision the next 5 years? Do you see it plateauing at all, slowing down and trying to consolidate and understand it better versus trying to just go to Chat GPT number 6 or something, or what?
So I think that actually there's two things there. One is that what they're going to try to do. What they're going to try to do is, make it as ubiquitous and effective as they can in order to, dominate the market and make money. So that's they being OpenAI here, but that's similarly for all the other players. Whether it's going to continue to radically improve or not, whether it's going to plateau, that's another question. And I think that the genuine answer that anyone should give you to this question is that we do not know. People will opine very strongly one way or the other. Oh, it's going to be a winter, just like it was in the 80s, where we thought neural networks were going to be, building HAL 9000 tomorrow. But it wasn't. So it could be like that. Or it could be that there's a massive breakthrough tomorrow with a totally new architecture, totally different from transformers, that's radically better. And the thing is that we don't understand why the things work as well as they do. And so, making confident predictions about how they're going to perform tomorrow when you hook them up to another 100 million GPUs, or when you use a new system, we genuinely don't know. My money's on plateau, but we'll see. I wouldn't take that recommendation to the bank.
So the original, one of the definitions I've read of AI is to augment human intelligence, not necessarily to replace it. So if a doctor receives a certain number of recommendations from AI regarding a cancer diagnosis, the doctor really still has to inject his own experience and human intelligence into the process. Otherwise, AI becomes relatively useless, right?
Yeah, so I mean, there's lots of cases where what we use AI, the task that we're using AI for, is to advise us, right? So remember the definition from Russell and Norvig that I'm using, I think is right. We should think of these as like, things that solve tasks rationally, or at least as rationally as a human would. That do a really good job at certain tasks. Some of those tasks are advice, like advising the doctor, giving recommendations, things like that. Other times we use them directly for decision making. An automated vehicle, they don't work very well right now, but they work way better than they used to. And the automated vehicle, the AI system that drives a car, it is just doing stuff on its own. It's solving the task of driving without further input. One thing about the advice role that you're just talking about, that if we're going to have the doctor use their expertise to help make decisions, this is one of the worries people have about opaque systems. If the doctor has no idea why this system thinks that this, this X-ray image shows cancer, then it's very hard to decide, like, should we listen to the doctor or should we listen to the AI? How can the doctor use it as an input in their decision, further evidence, if they have no idea why the system's making the decision that it is? So, this is one of the problems with the use of opaque AI systems, is that as advisors, they're less useful. But yeah, I mean, that's certainly one of the roles that we use them for and should use them for. And I would not be in favor of, using AI decision-making for lots of stuff that doesn't have human oversight. Not in its current form.
We have another question in the chat. This one is from Maria Pearl. Good afternoon. I'm a pediatrician at Boston Children's Hospital. I'm told that teens and college students turning in papers at midnight, perhaps in classwork, would be beneficial to students since there are no easy ways to monitor this. How will it be implemented in the medical clinic and hospitals?
Sorry, so the thought is that there's certain ways of sorry, can you run that by me again? I think I missed the.
I think she's asking how will AI be implemented in the medical clinic and hospitals?
I mean, one reasonable way that it's being implemented right now is as a tool for various specific tasks. So I keep going back to the radiology example because this is actually currently the case. We actually have AI systems currently being used to help doctors identify cancerous growths in radiology scans of various sorts, MRIs and CAT scans and X-rays. So that's currently being used right now, and it's being used as an automated help. There's other kinds of systems that are being used already. When it comes to generative AI, I'm supposed to be meeting with a resident doing a project tomorrow, actually, tomorrow, about using generative AI to create notes sort of automatically for doctors. So the thought being that visit notes can be generated automatically, and the doctor can look it over for veracity. So that's another kind of methodology. How do you police appropriate use of such systems? That's an interesting question that I suspect is going to have to be answered by specific details about the workflows in the hospitals. I don't know.
I'm just curious if you are feeling more positive about everything that you're learning and seeing, or nervous or apprehensive. Where are your feelings on it all?
I guess more apprehensive than good. There are definitely great things about these systems. And my apprehension comes from two things. One is that there's just a ton of hype about these systems, and it's misleading people. It's misleading people what they're good for. It's misleading people about how useful they are, whether they're worth producing massive amounts of carbon in order to use. It's misleading people about what the dangers are in ways that could lead to the wrong kinds of regulations getting passed, like so-called safety and alignment regulations, which OpenAI is pushing because, among other things, it would be a big benefit to OpenAI if small startups weren't allowed to build generative AI systems. So there's all kinds of reasons to be worried about these systems. The bias, the inaccuracy, the deep fakes. But my biggest concern, the reason why I'm apprehensive, is that precisely because we don't have the appropriate democratic oversight over these things. I think just like we need democratic oversight over power generation and other things that can produce carbon or things that can harm people's lives, surveillance, all of those things need to be better democratically regulated, and we don't have the infrastructure for that. Instead, what we have are a group of enormously powerful companies with enormous influence in the government, basically getting to do what they want. So it's not the technology itself that worries me. I think the technology is cool. It has some problems for me as a professor. Okay, makes my life harder. But overall, I think the technology could be really beneficial. The problem is that, like many other potentially beneficial and potentially harmful technologies, the people who are developing and using it are not getting the kind of oversight that they should.
Well, I know we're at the hour. Thank you so much. This was really great, and I hope this conversation with the Georgetown professor is one of many during these lunch and learns. This was fascinating. Thank you so much for your time.
Yeah, thanks for having me, everyone. It was great chatting with you all.
you.